Tiny language interpreter. 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 Tiny language
How's that for sound now? How's that for sound now? Right, okay. I'll up it a tiny bit. How's that for sound now? Sorry if you get a load of fan noises now. Right, okay. I'll up it a tiny bit. How's that for sound now? Sorry if you get a load of fan noise. There we go. I've stopped the infinite loop. Okay, is that better? Right, so what we're effectively going to be doing is writing something that both parses and evaluates a program at the same time. So this is little more than an expression parser at the moment. So we want to be able to evaluate expressions like these, but we want to express them in something called reverse Polish notation, which is where the operator comes first. So these two are completely equivalent, except this is in reverse Polish notation form. And as you can see, the resulting expression that we're dealing with is this tree here. It's represented by this tree. So, first of all, let's, rather than making it read a file or anything yet, so we use reverse Polish notation because it's easier to parse. Okay, so you don't need to read ahead in order to evaluate a bracketed expression, for example. All you need to do is look at the operator and you already know how many symbols are needed. So first of all, let's start off with a test program. So 5 plus 4. Now of course we know the answer is 9, but the idea is to make the computer work that out for us. So let's get rid of this for the moment. So the first thing you're going to want to do is to split your code up into tokens, which generally is pretty simple. You start off by taking your string and splitting it, because our language is incredibly basic at the moment. It's just things separated by spaces. So we're going to create a type for tokens first. So these are the things that are going to be emitted by our lexer. Now the lexer is the part of the program that takes the string and emits some higher level representation of the code. So at the moment we have a few different symbols we're going to want to have here. So for example, add, we want to represent an add token, and we want to represent a number token. And here we're just going to use a U32, a 32-bit integer for now. So let's create a lexer. Not a lexer as in the awful Amazon product. We're going to want to return a vector of tokens, not tokens. Isn't Lord of the Rings. And we return a vector because we want more than one of them, obviously. So the easiest way to do this is s.split. I believe you can do this. Split by spaces. Okay. Now this creates an iterator in Rust, and iterators are very fun because you can call more and more methods on them going down, and you can treat your entire program like a pipeline, where at each stage you do something to the things you're working on. So in this example, we're taking our initial string, we're splitting it according to the space character, we're going to filter it according to those that have a length larger than 0. So the problem is when we have two consecutive spaces, for example this, splitting on this gives us an empty string in the middle, and we want to get rid of that. So we want to filter where the substring is larger than 0. So we only get the substrings that have a length that's larger than 0. Now what we want to do is some more complicated logic. We're going to want to match on our string now and convert it into a token. So there are several different tokens. Squeaky chair, says make a lot of noise. I am recording it, yes. I don't know why I'm trying to type a response at the same time as speaking a response. I'm not very used to this. So plus is the first token we want to be able to pass, and when a value and this becomes a token add variant. I'm actually trying to point at the screen with my finger, which of course doesn't really work. Another thing we want to do, thank you Butsy for your compliment. I'm not sure how much I believe it, but so for any other token we want to work out whether it's a number or not. So for this we can attempt to pass the string. So you want to pass it into a number, specifically into U32, because that's what we have up here. And for now, what we're going to do, that work? No, I think it's a result, isn't it? So now we have an issue. If we have a substring that isn't a plus and can't be passed into a number, then logically we want our interpreter to produce an error, right? So the way we're going to do this is to return an error. However, this type doesn't exist yet, but we'll be creating it in a moment. So let's make this error something like unrecognized token. We're going to put S in there. So when we come to actually running this code, it should actually report the token that it doesn't understand. To make this work, we need to return a result. Okay, a result means that we can either have a vector of tokens or we can have an error as a result of our lex operation. External microphone, yep, I totally agree. I haven't got one because I normally never do this. I'll make sure to get hold of one. So let's just create an enum for our error type for all the possible errors our program could emit. So let's call it invalid token. It sounds a bit better. And we're going to make it take a string reference. Okay, we use this lifetime here because it's only a temporary string, and to make this valid we need to have a lifetime on the type as well. So, and because we have the lifetime on the type here, we need a lifetime here. Because of that, we need to bind it to the lifetime of this original string, because if you think about it, it's a subset. So this error string is a substring of the original string that we passed in, and so the lifetime of the error string is bound to the lifetime of the original string. They are one and the same for the same piece of data. So we just put a lifetime on here to declare a lifetime like that. And I'm going to zoom out a bit so it's easier to see it. Hello, Qtrin. Yeah, cool. Right, I just realised that on the stream a load of my text was being overlapped by the window. Sorry about that. Right. So, at the moment we still have an iterator. Oh, no, we should change this to map because we want to create a mapping between the substring and the token. Actually, shit, this isn't going to work because this is within a closure, and so returning won't work. Good way around this. Good way around this is to just use an iterator, to be honest. So we create a new empty vector for let's call it substring in, let's just move this bit over. Thankfully we can use an iterator in a loop. Yeah, that's probably the neatest way of doing it. Move all of this out and get rid of this. Right. Is that all correct? I think so. Right, and instead we just want to push that token onto the vector of tokens, and the same here. Tokens dot push token add. In fact, just to neaten this up, we can get rid of this extra load of brackets here. So I think we're about ready to finish lexing at this point, so we can give it a try. Now, it's absolutely inevitable that there will be a bunch of errors I've missed, and this thing totally fails to work. But let's give it a go. And tokens equals that. Oh, one thing I'm going to do is I'm going to derive the debug trait on our token type. This means that we can print it in a debugging manner. So so we can print the tokens that we have now. We're also going to do .unwrap on this because, as you can see, this returns a result, and the way unwrap works is that if the result worked out okay, it gives us the value we want. If it didn't work, it panics the program, which for now is just fine. So let's give this a run. Oh yeah, plenty of errors, of course. Expected str, found char. Okay, that's okay. I did a bit of a brain derp and decided to use a char instead of a string. This one, no variant named unrecognized token. That's because I renamed it, didn't I? And I forgot to rename it down here. Mismatch type. Expected result. Oh, that's because we're not even returning the token vector. So let's just do that. In Rust, you don't need a return at the end. The last expression is considered to be a return value. So let's run it again. .unwrap. Okay, so the reason this doesn't work is that unwrap only works on results where the error type implements debug. As you can see, it's a bit sort of wordy here, but the following traits weren't bound. The trait debug was not bound to the type error. So very simple, we just do the same here. And now we have a proper error type. Let's give this a run. As you can see, we have an invalid token error. So what happened here? As you can see, it tried to pass the entire thing as one token, which is wrong. So what happened here? Oh, should be using substring here, not S. S still refers back to the original one. Actually, I'm going to rename this. I'm going to rename this code so it's a bit more clear as to what it is. So we split the code according to spaces, filter it according to those that have a length larger than 1, and then attempt to pass it into a token. So let's give that a run again. Oh dear, another error, just because S is no longer defined. We should use substring here too. And there we go, that's good. We have a result. I don't know how visible this is on the stream. Is it visible? I'll make it a bit larger. There we go. So as you can see, we have a vector of tokens. We have an add and 2 numbers. Okay, so we've taken our code and turned it into something that's a little more meaningful for the computer. The next thing we're going to do is, because we're not writing a compiler, we're just writing an interpreter. Next thing we'll do is we're going to interpret it. So I'm going to create a function called eval, which just means evaluate. And it's going to take a reference to a slice of tokens. So a slice is like a little window into an array. If you're familiar with C, it's like taking both a pointer and a number corresponding to the number of items you want to look at. And the nice thing about a vec in Rust is that if you take a reference to a vec, it will automatically coerce into a slice, which means Rust will be clever enough to work out that it needs to cast them. And then the result of this is going to be, of course, sometimes we might have a program that contains an error and so it can't execute. Oh wait, question. Blah, 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 blah. How did it work considering you still have S in the filter? Oh, okay, so right, S here, this is what's called a closure. It's its own little function, okay? And in a closure, these 2 bars describe the arguments going into the closure, okay? And this little bit is its own piece of code that returns a boolean. So as an equivalent, we could do something like this. Let's call it something sensible. So we've created a new function. We're just going to make it return exactly the same thing. And you can see how there's an equivalence between closures and functions, because this will still work. It's like using a function pointer if you're used to a language like C or C++, although C++ has inline lambdas, which are basically the same thing as closures. Does that answer your question? There's probably a delay on the stream, so I'll be waiting here for a moment. Make it a bit smaller. Yeah, so closures are really powerful and really I've got rid of that code, I want to keep that. Closures are really powerful and really useful, and you'll find yourself using them a lot when you write Rust. They allow you to write really condensed, easy to understand code. So we have our eval function, and we take as an input that token stream that we previously found, and we produce a result. So actually I'm just going to move this print up here a bit, and now we're going to add another print ready for when we need to test this, that will show us the result. Actually, we don't need a debug print here, we can just do a normal print because it's only U32 that we're going to, actually no, should do a debug print because it may produce an error. So we're going to want to return a result, U32. Actually, I'm going to change this to an I32 simply because we may have an expression that produces a negative number. Just looking through the chat. Yeah, so that's absolutely right. It's its own little mini function, which you would think comes with a load of overhead, but actually the Rust compiler is really good at inlining them, and it basically compiles down to the equivalent that you'd normally write in C, for example. It's just a really ergonomic way of writing fast and readable code. Yeah, so you do, that's totally right. Yeah. So we're going to want to return an error, of course. We don't know what kind of errors can be produced by this at the moment, but we're just going to assume that there will be some inputs that it can't evaluate, so maybe there's an undefined variable or something like that. So the first thing we want to do is understand what problem we're trying to solve. So I've gotten rid of it now, which is kind of annoying. Actually, I won't try to write it out again. But we had a tree that defined our expression, okay? And it allowed sub-expressions or expressions inside other expressions. So for example, we could go for something really complicated like this. And we'd still want our program to be able to evaluate it. And as you can see, this is an add expression inside an add expression inside an add expression inside an add expression, etc. Now you've all watched Inception, so it should be fairly obvious where this is going. We're going to want to use recursion, and recursion is an extremely powerful tool in the programmer toolkit, and allows you to write some really elegant code that works usually if you get it right. It's sometimes a bit confusing, but it usually works. So the first thing we're going to want to do is we're going to want to make sure that this slice here of tokens actually has a token in it at all at the beginning, okay? So the first thing we're going to do is if let sum first token is equal to tokens dot, let me Google this very quickly. I think it's just dot first. There we go. Yeah, it is dot first. So what we could have done is something like this, but the problem with this is that if the slice is empty and we try to get the first token, Rust will panic, and we don't always want to panic. If there's no token in the slice, we want to produce an error and actually handle the error in a proper, more sensible way. So this is why we use this sort of if let expression. If let expression here. This is called a pattern matching expression. So a bit like the match statement here. We're effectively matching on whatever this produces. By the way, it'll produce an option. It'll be something like this that it'll produce. And we're going to want to check if it's a sum rather than a none, i.e. the value actually exists. And if it does, we're going to want to match on the value, okay? Or rather match on the token, okay? Match token. So the first thing we want to check is whether it's an add. Actually, what we also want to do is handle the case where there was no first token. Now this is the sort of place where we want an error. So it's good we added a result in the first place. So we're going to do something like error incorrect. No. Let's just go for invalid program. Easy. And then need an error variant around it. Invalid program. Yeah. Let's just, because we have the lifetime up here in this other thing, we have to add a lifetime here. It's a bit annoying. Or an alternative is actually we just, instead of tying it to that old lifetime, we just convert it to a string directly in the original function. You can do .to owned, which then turns it directly into a string rather than a slice. So we no longer need any of the lifetimes because Rust can work out how the lifetimes are working. Okay, so in the case that it's an add, there are two things we want to do. First of all is to read one sub-expression, and the second thing is to read another sub-expression. So we're going to add another function called actually, are we? Yeah, we are. Okay. We're going to add another function. No, we're not. Called let a, so the first operand. So imagine we have something that looks like this. We're going to want to get this first operand, and we do that by calling this same function again, eval, but this time with just everything past this first character, which means we can use this same slice but we split it like this, which means everything including the item at index 1 and onwards. So if you imagine the indexes look a bit like this, etc., right? So we want to start at 1 onwards. And then the next one is we're going to want to start at, well, we could start at 2 onwards, but here's the problem. What if we wanted to make a actually another sub-expression? Let me just check the chat again. Code is cut off, right? Yeah, I'll make that a bit smaller. Thanks for warning me. I should probably check the chat a lot more. Right, so what if we want to make a sub-expression in the case of a? Well, we can no longer read from 2 because it's then counting part of that sub-expression. So the solution we need to have is to make this function return how many tokens it read. So we're going to return a usize, which is just an unsigned integer effectively, that corresponds to the number of tokens that were read by the program, okay? So A and then A skip is equal to however many it read, B skip. So B skip and A skip are the number of tokens that got read when we tried to read a token, okay? So now what we're doing here is we're reading from the offset that we found when reading the first token. So let's say this bit here is A. Actually, let's make this comment a little bit clearer. This is A. And this is B. I don't know how clear that is. It might not be very clear at all. This bit here is A, this bit here is B. So when we read A, we'll get back a number, and it might say, oh, I read three tokens. So A skip becomes 3, and then we add A skip to 1, and we get 4, which means it starts reading at the offset 4, which is coincidentally where B is, which is what we want, right? So now when we have these two values, A and B, the only thing we want to do is just add them together, and we have our answer, right? And now we're going to want to return an OK, because we found our answer and we want to return from the function itself. So A plus B, then we want to also return the number of tokens we read, which in this case is that first plus, so one token, plus A skip, which is the number that we read from token group A, plus B skip, which is the number we read from token group B, okay? So in our case, this would be 1 plus 3 plus 1. 1 plus 3 plus 1, okay? Which means that the entire expression was 5 tokens, okay? Right, and there's one more case to handle. The case when it's not a token add, when it's a token number. Let's see how I define that. Yeah, it was just that. It's a bit too big. Well, okay then, making sense-ish? Or am I completely losing people? So, when it's token n, we want to return just OK, which is n, and the number of tokens it read, 1. So to just clarify a bit what's going on here, we first call eval for this entire slice, okay? We get to here for the first token and we realise it's a plus, okay? So then we call eval for the next bit here, which is A, our sort of A group, okay? And then it itself finds another plus at index 1, so it calls eval again, but now we're on this index here, and we don't find a plus, we only find a number, and a number just evaluates to itself. It's just sort of a literal expression. It is just itself, and since it's only ever one token, we just return 1 for the number of tokens read, okay? So that pretty much concludes our program. So let's give it a run. And loads of errors, of course. Well, it is Rust and it insists on doing things correctly. So line 60, why does it keep on zooming in? That's really annoying. local variable already exists. Oh yeah, we called it tokens and not token. Next one, expected a token slice. Oh, consider a borrow here. Oh yeah, so slices are borrowed, hence the reference bit here. So we just need to add a reference here to say that we're borrowing the slice. Nothing too confusing. And this is the same error here. This is a thing, look. It's saying, oh, this A and A skip bit can't match the result of an eval because the result of an eval is a result, okay? What we want is this tuple inside the result. So what we're going to use is the super awesome question mark operator, which to Rust says, if this is an error, return the error and exit the function. If it's not an error, then just give us the value that we want inside. So this bit here, this tuple, and that then gets moved into this place. And we want to do the same with B as well. Okay, now let's try running it again. One last error. Expected an I32, found a reference to an I32. So the problem is that since this is a token slice, we're only getting references to the tokens. So that means when we match on the first token, this N here becomes a reference because it's inside a token that's a reference which was inside a slice which was a reference. So the very easy thing to do is to just dereference it because it's an integer, and then it turns from a reference to an I32 to an I32 itself. So let's run this, and we can see, there we go. Magic. We can see that our program here, +5, 4, has evaluated to 9, and it read 3 tokens, which is completely correct. That's what we wanted. So now let's try whether it can handle more interesting and complicated expressions. So let's do sort of a chained addition type thing. So, oh, that won't work because we're using reverse Polish notation. So let's run this and see. We get the, well, what I assume is the right result. I'm just going to check that on a calculator because, yeah, I don't want to trust my program yet, given it's actually the first time we've run it. And yep, it's the correct result, which is rather nice. Nice when things work. So now we can do something a little more advanced. At the moment, we've only got a plus operator, but what we really want to add is more operators. So let's add now. Let's add 3 more. Let's add subtract, multiply, and divide. Okay. Yeah. So what we've got to do now is we've got to change our Alexa code. So sub, multiply, divide. Oh, divide. Div, mul, sub. So there we go. It can now recognise those tokens. And now we want to do the same for these other tokens here in our evaluator. Sub, then instead of this we just do a minus here. Mul, instead of this we just do multiply here. And div, so instead of this we just do a divide here. Really simple. Now there's a lot of sort of code here that looks like it should be reused in some way. We probably can move it out into a separate function, maybe one that does something like read binary or whatever, so binary pair of expressions. But I'm not going to do that right now because this is just a small example and not a tutorial on how to write a fully fledged compiler. So we're just going to go for the basics at the moment. So let's try something a little more complicated. Let's make up a calculation that's a little more complicated. So I don't know, 5 plus 8 times 12 minus 42 times 2. Okay, and let's just bung that into Python to work out what it is. 17 apparently. So if we get that result, we know we've done well. Let's just clear the terminal so we can see what we're doing. So let's convert this into reverse Polish notation. Now the first thing to remember is that BIDMAS, you may have learnt in school, or BODMAS, multiply has a stronger precedent than plus and minus. So we do those first. So in this case we do multiply 8, 12, okay? Then the next expression we have is the 42 times 2, so times 42, then 2, okay? And now we're going to want to add 5 to this part, the 8 times 12, so plus 5, 8 times 12, and then we're going to want to subtract the 42 times 2 bit, so sub, and put the 42 times 2 on the end. Okay, so we have minus this from this, then add this to this. Fairly simple. So what result did we say we were going to get again? 17, wasn't it? Yeah, 17. So let's bung that reverse Polish notation expression in there. Let's give it a run. And there we go. We get 17, which is quite nice. It's nice to see things actually working. Yeah. I probably need to start getting ready to go to the game jam thing soon, but thanks all for watching. Hopefully this was a interesting little lesson. I'll put this up on a GitHub gist so you can play around with it if you want to. Let's call it reverse Polish, so RPN.rs or something. RPN interpreter. Right, I'll put that on the Discord now. Okay, where am I going? There we go. Feel free to play with that, feel free to have a bit of fun. In terms of posting the recording, I'll do it now actually, I've got a bit of time. I'll probably put it up on YouTube, it's the most convenient place. Yeah, so see you later. Bye.